have three different types of space. One is
Okay.
permanent space. Sometimes they will be asking in interview also. One is permanent space, the spool space, and the temporary
Okay.
space. Temporary space. Permanent space is nothing but it is a physical space that the Teradata objects will use that. Okay, something like tables, the views, and the databases. So users, it will be users all the space. It's the physical space it will be used. Like whenever you are creating a table, right? So it will allocate some permanent space. So whenever you are creating a database, you have to give all these three spaces. If you are trying to create a database, you have to give three spaces. One is permanent space, pool space, and temporary space. Okay, permanent space is like so if you are having 1,000 terabytes of database, so how much you are going to allocate for permanent space? Okay, then spool space, then the temporary space. So normally permanent space will have more spaces. And normally you have a database whenever you are creating, right? So database tables, users, all those it will take, the views will take all the permanent spaces. Then you have the spool space. Spool space is nothing but unused space. So unused permanent space is called spool. So you are running on query, on complex query you are running. You are running some rank, something like the rank. You are finding the rank, or you are doing some aggregations. Okay, you are doing some subqueries. All those you are running on BigQuery. You are running. It will take a lot of space, right? For example, you are going to run a rank function on one particular some millions of data, then it needs to compare with all the millions of data and it needs to do sorting. So it will take some space to do the sorting algorithm, or you are finding some distinct or rank or sorting or aggregation like minimum, maximum, sum. You are doing some aggregations. Then it will take a lot of space. That space will be taken from the unused space. So I told, right. So if you have 1,000 terabyte of hard disk space, if you have allocated 500 GB for 500 TB for permanent space, the remaining something like 400 TB you are using for spool space. That 400 TB will be allocated in all the amp. We have some 10 amp or 12 amps or 24 amps. So how many amp we have? That whatever the space we have left out for the spool space, right? It will be allocated in all the amp. So whenever you are doing some intermediate calculations like subqueries, aggregations, joins you are doing, so that spool space will be used, the unused space. So we need to assign the upper limit of the unused space. That what is the spool space for each and every user. For example, you are one of the user for that particular database, right? For each and every user will have one spool space. For example, if I am the user for database, then each and every user while creating the user ID, they will allocate what is the maximum spool space they can use it. If they are allocating like five,
And explicitly, we have to like we have to mention it or what? How we will create
no,
the
no, no,
spool space?
we are not going to
That
mention
way,
it.
right?
We are not going to mention it. The DBA will mention it. Normally that automation process nowadays, right? They will go to particular the front end tool. They will make them user ID and password. Then it will create the user ID for the database based on the roles. Then it will allocate automatically for that user what is the based on the roles. It will allocate the spool space, one particular
Oh,
user. That
oh,
spool space you have to use it. Okay, no other space you cannot use it. For example, you are running a complex query that is requiring more than the spool space, you cannot run that query.
okay,
You will get another like spool space issue. No more spool space
oh,
issue. Okay,
oh,
the spool
oh,
space
oh,
is nothing but unused permanent space which is used by the system. Okay, Teradata. So similar to a permanent space, spool space also you have to define a maximum amount when you are creating the user. Okay, and also the spool space is divided by the number of amp. So whenever you are creating the user, right, that time the spool space, the maximum limit will be assigned. So this is like something like a manual query, something like the DBA will use that. So create username. This is like data warehouse production admin. So admin user ID
okay,
they are creating from data warehouse PRO. That is one of the, might be they are having some database as permanent space is this many bytes. Out of this, spool space is this many bytes. This something like 2 TB or 2 GB, 20 GB or something. this 20 GB can be divided into all the amp. If I have something like 10 amps in the database, then the spool space will be divided into 10 amps. Okay. So when will you get no more spool space? Whenever, for example, if one of the amp is getting skewed, okay, if you are not selecting proper index, right, for the particular table, if one amp will get skewed, right, it will get more values. So it will have some space. That space also it lies. Then you will be getting no more spool space. So you have some 4 amp system. If 200 GB is allocated for totally for the spool space, like 24 amp system, then each amp will get 8.3 GB spool space. All other amp is using within 8.3, but one amp is using 10 GB. Then you will be getting spool space issue. No more spool space. Okay, got it. If any one of the amp is getting issue, then you'll be getting no more spool space issue. Okay, even if the query is skewed, then definitely you'll be having that spool space issue. So to avoid that spool space issue, what you need to do? First of all, you need to run that query. You go for the explain plan. So if you are running on query, right? For example, you are running select a distinct of some ID, okay, product ID from the table. It has so many product ID. You are running some select distinct of row ID, something like you are making some inner query and then you are making some distinct value. Then it is taking a lot of issue and then it is showing like no more spool space issue. It has been errored out. Then what you have to do, you have to go for explain plan for that query. Then it will show you where is the error. Okay, so you do collect stats. Okay, you do collect stats, check whether the table is a set table or multi-set table. You go for multi-set table. You are fetching on table, right? Selecting a table. That table you check it whether it is a set table or multi-set table. Even insert statement also you'll be getting some spool space issue. It will take a lot of time to process it, insert it. So why? Because you are creating a set table. While inserting it, it will take a lot of time to insert. It will be checking the duplicate, right? Then it will be taking spool space issue. That time you will create a multi-set table. Then it will easily it will load into the table.
You said like if you create a multi-set table, then this issue will be resolved. Na? That's what you told, right?
Yeah, yeah. Why? Because you are having set table. Set table will check each and every record. It will check the duplicate, right?
If
Record.
we create the set table, then this skewness problem and all will be resolved. Na? Then there will be no spool space error. Na?
No, 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 no. Set table. You are inserting the record into the set table. Something you are selecting in different table. You are doing some insert into select operation you are making. So it will be selecting some queries and then you are loading into a set table. This time the set table will check each and every time it will check duplicate. Okay, duplicate check, right? Whether it
Okay.
is a duplicate record or not, a full row duplicate it will check. So even though it will not insert duplicate record, okay, set table will not insert duplicate record. Okay, it will you are going for insert into some
Yes.
select star form, it will not insert duplicate record, but each and every time it will go and check whether it is a duplicate or not. So that is why it will take a lot of spool space. You will be getting an error out.
Oh,
That time
okay.
instead of set table you go for multi-set table. You
Multi-set
load
table.
it and then if you have any duplicate you can rectify it. And also you go for explain plan. That explain plan you check the join indexes. Okay, how the join indexes is, whether it is going for 1 amp operation or 2 amp operations. Join index you check and you check something like skewness also. Okay, so the
Oh,
explain plan I will tell you after some time. Okay, while checking the
okay.
some query I will do the some explain plan. That time you can get to know that. Check for proper index whether it has been indexed properly defined or not. Sometimes no index also it be available. Something like no primary index table. So that time you will not have some spool spaces you will be getting. So that time you have to do it. Okay. This is what the spool space you will be getting another. These are like something like spool space. Definitely you will be getting this issue in real time. Okay, so that time you have to go for the explain plan and then you have to check whether you, the first thing is you can do collect stats on the column.
Okay.
Okay, collect stats on the column. You check multi-set table or set table.
Okay.
So then these two things you can do immediately. Okay,
Mm-hmm.
then you can check some index column, indexing, join indexing, how the indexing is, whether it is going for something like Cartesian product or not, If it is going for Cartesian product, definitely it will have lot of spool space. Okay. To avoid that, you have to do some join columns very correctly. For that, you can go for some join index you can create on top of the table. After this temporary table, we will go and see the join index. So join index you can create to reduce that kind of issues. Okay. And the skewness also it will be showing you whether you have the particular column is having more duplicate data, then you can avoid the data while bringing it itself. Okay, something like you can go for rank column, dedupe, you can apply some dedupe logic, you can remove that duplicate on the particular column by using some rank function, the qualify. Then you can go for this temporary space. What is the temporary space? It is the amount of space, okay, it is the amount of space used by the global temporary table. Okay, temporary space used by the global temporary table. Got it? What is global temporary table? I will tell you. Global temporary table, I will tell you. These are the three different spaces are available in Teradata. So for example, here, this database we are having, right? We are the admin for this database. In real time, you will not have access to this particular page. This tool you will not have access. So here, this is what my database. I'm going to create the database. I can create a database and I can create a user. If I want to create one database in the sense, you'll have multiple database inside the Teradata, right? So I'm going to create one database. So database name it is asking, right? Asking who is the owner, and it's asking the permanent space, correct? Spool space and temporary. So this is what it will ask. So either it is a fallback. Fallback means even every space, the database, it will have one more memory. Before journal, after journal, even journal concept also, it will take a lot of memory.
Then if we set all these options here, then all the tables, the database will be by default will set to these properties.
Yes, correct. The entire database itself, it will be a fallback. Before journal, after journal. Journal is nothing but you are writing, inserting, updating record into the table, right? Like we are having some paper and then we are writing it. If something goes wrong in between, how the data will be stored, where up to where it will be stored. That is what the journal. I will tell you. So that is also saved, right? How it is going to be. So it is like a journal. Okay. These things they will be giving us. This one we will not use, but in real time it will be automated process. Okay. They will not use like manually. They will have some tool. We have the temporary table. We have three different temporary table. One is like derived table, volatile table, or global temporary table. Okay. Global temporary table. And the third table is we will call it as the volatile table, volatile temporary table. What is this? We will see one by one. So derived table, we don't have control. Okay, derived table, we don't have control. The Teradata will take care of the derived table. So something like inline views in Oracle. Okay, inline views, you know, right? Whenever you are having some subqueries or joins or anything else, we are making alias name, the table alias, right? Or we are making some subqueries. For example, this is the query we are making. Okay, so one query we are making, some subqueries we are making. That queries we are having some inner query we are aliasing like A or B or something. We are making this query as A or B or something. So this is one query like T we are making. So what is this T? Whenever you are going to execute this query, that time it will execute this inner query. At this instance, it will execute this query. It will save this result into a table called T with the product ID and sales. A table will be created. It will be called as T. So from there, it will take the outer query. And once the query has been executed, this table will get vanished. This table will not be available. If you are going for select star from T, it will not be available. This is called derived table. Teradata, it is called derived table. Okay, derived table maintained by Teradata only. We are not able to create any table. So next one is like volatile temporary table. So what is that volatile temporary table? Normally, if you are doing some intermediate calculations, right? Intermediate table, you want to create storage of. You are having very big query. That query you are going to divide that query into multiple stages. Like you are storing one data into a table. Resultant of this table you are storing into another table, then another table you are doing some transformation logic, another table, then final table you are loading. Instead of doing all the logic into a single table, single query, you have split that query into multiple temporary table.
like stage work and final tables or
No. That is
how?
different. That is different. That is physical table. This is not a
Oh,
physical table. So this is a physical table only, but it
okay.
will be created only that instance. Okay, once that session has been completed, that job has been completed, this table will get vanished. Automatically it will get dropped. This table will not be available. Okay, the space will not be used, the data will not be available, and the structure of the table also will be get vanished.
Okay.
Global temporary table also, it's a temporary table. Okay, so you can use it for some other purpose, but the DDL, okay, the structure you are creating something, create table, table name you are using, right?
Mm.
That
Yes.
structure will be maintained for other sessions also, for other users also.
Uh-huh.
So if I am the user, I can use one table called GTT underscore one. That is one table. It has some columns I'm using. So I have used the table for to store some data, and then I have come out of the session.
Okay.
If you are another user, you are entering into the database, and then you want to use the table, you can use it. Once you come back, your session data will get vanished, but the structure will be maintained. The structure will be maintained in the global dictionary. Got it? So I'm going to
Okay.
create one volatile table now. Okay, I'm going to create one volatile table, then I'll show you. I'm going to create one volatile table. For example, the retail database I will create. Okay, so in there you can mention create table name and the retail dot something, or so I'm going to execute the syntax called database retail. I'm going to execute the syntax called database retail.
Bit.
That means no need to mention the database name every time.
Mhm.
Okay, one time I have mentioned here, then all the times it will be retail table only, retail database only. So I'm going to create a volatile table now. So create volatile table, table name, something like
Mhm.
log it will take, it will be maintained for log, department number, average salary, maximum salary, something I'm creating. On commit preserve rows, it will preserve the data. If you don't use it, then it will not save the data. If you don't use this on commit preserve rows, it will not store the data in the table. So here I'm going to create a volatile table. Table has been created, right? In this instance, it has been available. So I'm going to insert some record into the table.
Generally, in which cases in real time we will use these type of tables?
Yeah, that is what. So that I told, right? So if you are having very big query or very complex logic, you are going to use it. You can split up that complex select query into some small select query. You can store it into multiple volatile table. After that, you can combine it, and then you can have it in a single table. Okay. Then after combining it, no need to keep this table, right? What is
Okay.
the use of
Oh,
this table? It
yeah.
will occupy space if you keep it. Every time if you are creating a table, temporary table, it will occupy the space, right? So instead
Yes.
of that, we are banishing the table. For that purpose, we will go for volatile table.
Alternative. Yeah.
So
No,
now
it's
I'm going to insert a record into the table, volatile table.
okay.
I'm going to insert it. So one row has been inserted. So if I go and check now, select star from the table name, it will be available. The data will be available. The table data is available, right? So simply you have to mention create volatile table. That's all. If you go and check now, so select star from the table. If you check the definition, it will be a create set volatile table. It will automatically it will create set table only. If you want to create multi-set table, you have to create multi-set table here. Create multi-set volatile table on the table. Fallback has been enabled for this. This is a volatile table. Clear?
Oh,
Set
okay.
table, multi-set table, you can create it. So now what I'm going to do, this is I told, right? Only that instance only it will be available, right?
Oh, yes.
Instance only it will be available. I'm just a log out. I'm doing some log out. If you have created any table, if you log out and log in also it will be available, right?
Yes.
But
But here
but
we
volatile
don't.
table will not be available. See now,
Well, yes.
volatile table will not be available. So it's
Correct.
showing like so I will execute database also. Okay,
Mhm.
I will execute select star from the table name. The table showing like does not exist. Why? Because everything will get vanished. If you
Understood.
don't use on commit preserve rows, if you don't use, for example, if you don't use on commit preserve rows, what will happen? it will not store the data. Okay, I'm going to create a volatile table.
Mhm.
A table has been created. After that, I'm going to insert some record. So one row processed, but if you go and check now, data will not be available. See now, if you use on commit preserve rows, then only the data will be preserved. Same instance also, it will not be available. Okay, this is called volatile table. Are you clear? Volatile table. It will not
Yes.
have that structure as well as data will be get vanished.
Not even structure
So
also.
whenever you want to have a table, it should not be maintained after the session. After the job completes, then you can go for the volatile table.
Okay.
Global temporary table is only difference is the structure will be maintained for all the session. The data will not be maintained. Data will get vanished, but the structure will be maintained after the session also in the
Temporary
global
table.
temporary table. Why? Because it's a
Here.
global. Anywhere
Yes.
anybody can use that. Create set global temporary table. So retail dot gtt. This one I'm creating it. Okay, on commit reserve rows. Just it's a global temporary table. Right? It has been created, right? So after that, if you want to load some data, the GTT, just I'm loading the data. If you go and check, this data will be available now. Select start from the table name to be available. Okay,
Yes.
to be available. So you are after that you are logging off your instance. You are logging off your instance. Again you are logging in. That means your job has been completed. Assume that it will log out, right? Once job completed, it will log out.
Yeah.
Again you have logged in.
Only structure will be maintained.
Yeah, only structure will be maintained. Okay, so retail I need to make it. So table is available, but 0 rows returned. This is called global temporary table. So structure will be maintained. Okay, but no data will be maintained.
Okay.
So others, if you want to use the same structure, they can use it. No need to create and every time. So other users and also that instance only it will be available. The other instance, the data will be different data also you can use it. For example, if I'm the user, I'm using this instance, some other data. The same time you are using the same global temporary table in your user ID, it will be different purpose you can use it. Okay, so that is called the global temporary table. So this is the three different tables which we are available. Derived table we don't have control. The Teradata will take care the control of derived table. So we have DBC, right? DBC or database computer. We have different tables are there in the DBC. Different tables are there in the DBC. So DBC dot tables, it will give you the all the tables information. DBC dot tables. Even tables V is the view on top of table. They would have created one view name. So if you check this, so they have created one replace view name as select dbase dot database name everything. Okay, table they have done with left outer join. They have created on view. Okay, so this is the view we do have. On the dbc dot tables v we can select it. If you are selecting it, you can check all the tables. So the database name, table name, so how many times the table has been created or altered. So alter or replace the version. Table kind is the either it's a table or view or indexes, so you can see the different table kind. Okay, and then so table kind I will tell you. So this is the abbreviation for all the table kind. Okay, so no pa table, it will be your table kind o. Okay, T means the table, V means the view, H means it is a instance or constructor method, and M and F. F is nothing but scalar UDF, M is nothing but macros, J is nothing but journal, the indexing, join index, I is nothing but join index, G is nothing but trigger. So we have something different table kind we have. So it's a fallback or no fallback. So that is the protection type. Journal. So whether we have journal or not. Who has created this table? Okay, what is the syntax of the table? So when it has been created, who has created? Okay, last altered by, everything will be maintained here. Whatever the SQL we have executed, right, it will be available on the history. view history, show history here. So whatever the SQL we have executed so far, right? Whatever we have executed will be available here. From the beginning, whatever we have executed, it will be available here. So all the SQLs will be available here. PC.users, it will give you all the users. How many users are there? It will give you the users list. So different users. How many users we have? DPC dots all space. You have all the space. Uh, what is the vproc number? So database name you can go for retail. Okay, account name, table name, how many space, permanent space, spool space it has been taken. It will show you where you can mention like name equal to, and the table name we have created one table, right? Morning we have created some table like retail. The country table we have. So current permanent space, this is the space it has been. Spool space it doesn't. So whenever we are running any query only, it will take spool space. So permanent, it doesn't take any much space here. So while running the query, it will take the spool space. Then dbc.index, it will give you all the index informations. You can run Teradata in two different mode. One is Teradata mode, the ANSI mode. So whatever we are running it, right, it's a Teradata mode. So you can check all whenever you are running Teradata. It's by default it will create a set table. It is not a case sensitive. So whenever you are running any query, it will be automatically commit. Implicitly, it will commit. Supports all Teradata commands. It follows BTET, begin and end transaction mode. So ANSI mode is different. So ANSI mode by default will create multi-set table and case sensitive also. The query. Even you can check that which mode is running. Help session, right? Teradata mode. Okay. I told, right? Our database is running a Teradata mode. In your database, if you want to check, you can go and check real time which mode is running. So by default, it will be Teradata mode only. So index, you know what is that indexing? Now those primary index, secondary index, partition primary index, and no primary index, right? This join index something different. This join index, whenever you are creating a base table, you will have the indexing. But you are querying the table based on some other column. Okay, some other column. So that time, the performance wise, it is not that much improved. Why? Because you have created index on one column, but you are querying some different column. That time you will not have that much amount of performance. This join index, you are telling Teradata to create. Okay, you are creating a join index. After that, the Teradata will take care. We are not going to see that join index. We are not able to see that join index. Okay, so if you are going for index creation, the Teradata will take care. Join index something like views, how we are creating the views in Oracle, right? On top of a table, we are creating the virtual table. To access it, multiple tables. You know, right? Views. What is views in Oracle? It's a virtual table. So like you have multiple tables are there. So always you have to fetch the data from multiple tables every day. So every day, instead of writing a query to join all those and then take the record, you'll write one time as the view, you save it in the database. Then if you are making select star from view, then it will pick the data. We are not going to run any query. The Oracle will run it. The same way, the join index we can create, okay, created by user, but maintained by the Teradata. It is an optional index which may be created by user. It will be for additional efficiency. It will eliminate the base table access. The main thing is it will eliminate the base table access. Whenever you are going for something like select star from the table name, you are not accessing the primary index column, which we have already created. You are not having that column. So you are using some other column. Then Teradata will check that whether we have created join index for that column or not. If you have created, it will run that join index and then it will pick the data. It will eliminate the aggregate processing, reduce the joins, and reduces the redistributions. So how it will reduce the redistribution, I will show you. So this is what. So you have 7 different types of join indexes. 7 different types of join indexes. One is single table join index, multi-table join index, multi-table compressed join index, aggregate join index, sparse join index, global join index, hash join index. These are like the 7 different join index are there in Teradata. So the first one we are going to see like single table join index. You assume that you have table called employee underscore table. You have the table called employee underscore table. So this table, this employee underscore table is having primary index of some other column, primary index of some other column. But we are not going to access that particular column as primary index. So for that, we are going to create one join index on top of the table. On top of this employee table, we are creating one more indexing. Create join index, index name, employee underscore index as select star from the table name, primary index of department number. In the base table, employee number may be the primary index. But in this index table, we have created department number is the indexing. Single table join index duplicates a single table. It will duplicate the single table, but changes the primary index. But changes the primary index. User will only query the base table. Okay, only query the base table. But parsing engine, right? The Teradata will access this join index. Will access this join index to fetch the data based on department number. This is called single table join index. You are having one table called employee table. Okay, employee underscore table.
Okay.
It has something like a column called employee number, department number, first name, last name, all those. Okay.
Okay.
Check. So this table has employee number, department number, first name, last name, salary, all the column. In that table, we have created employee number as the primary index. If you are making show select star from the employee table, it will show you this table structure only. But on top of this table, we are creating one indexing, single table join index. Okay, if you want, I will create and then show you. You are creating this table, the retail employee table you have created. Okay, if you are making like show table name, it will be available. On top of this table, we are creating a join index. Create, okay, single table join index, right? Join index of on this table only. Okay, create join from this table. Okay, so we have to mention that the primary index of which column we are going to make, and also join index where we are creating it. So this time it has been created. Okay, but this time if you are going for something like so select star from this table, show table name, it will show you that employee number as the primary index. Employee number is the primary index. But whenever you are running query based on department number, the parsing engine will take this query. This index it will take. It will be faster. Okay, this is called single table join index. This index we cannot able to see that. Our Teradata will take care. But this table we are creating a single table, right? So multi-table means instead of single table, we are going to use multiple table. The joins we will use. Okay, it's a join index that involves 2 or more tables. So join operations to eliminate the data redistributions. So I will show you what is that. So here we are having the employee table, right? Employee table as E, inner join department table as D. We are making something column, right? This one, and we are making a primary index on employee number this time. So whenever you are going for something like joins on these two table, this join index will be invoked automatically. This join index will be invoked. Clear? This is called multi-table join index. Multi-table join index. Compressed join index is nothing but, so instead of the compressed join index is nothing but repeating the, is designed to save the space, not repeating the repeating values. Same column names we are not selecting it. Just simply we are making like select c dot customer number, customer name, order number, order date, order total. So this is like C, this is dot order from customer table as C, inner join order table as O, and the same thing we are make it like. Okay, so if you are making first bracket, it will assume that the first table, second bracket it will take it like a second table. It will be very easy to understand by the Teradata. So this type we will maintain. in the compressed join index. So this one just we will create it whenever you are going for the something like explain plan I told, right? Explain plan. That explain plan, it will show you like create join index, something it will tell you. That time we can create it join index. That time you should know what is join index, either single table join index, multi-table join index, aggregate join index, something, but you will use some group by columns. So if you are using some count and group by, that select statement, you can use it like aggregate join index. Sparse join index, something like where class. So you are using some where class, right? Something like where class if you use that where class. So join index that doesn't use every row because it has a where class. Why? Because you are restricting the data. It will not use that all the rows. Anyhow, you have restricted the data from this year alone, 1999 alone. So this is called the sparse index. Okay, so whenever you are restricting the data, it will go directly to this view and then it will show you. This is like a sparse. And hash index, so something like hash value will be created. We are not going to handle it. The Teradata will handle it. Okay, create hash index, index name, department number, first name, last name, and table name. Okay, one hash value will be created in the amp level, it will be created, it will be maintained. We are not going to create it. So these are like different types of join index which we are using it in the Teradata. Join index is something like views we are creating. We are telling Teradata, instead of using this indexing column, you use another indexing column, that's all.